Bismillahirrahmanirrahim. Assalamu alaikum students. Our today's topic is binary multipliers. As we know that multiplication of binary numbers is performed mostly in the same way as of the decimal numbers, and the process of multiplication in the process of multiplication, the multiplicand is multiplied by each bit of the multiplier, starting from the least significant bit. Multiplicand multiplier starting from the least significant bit. Each such multiplication form a partial product. By multiplying the least significant bits when we start, then we obtain a partial product forms. Successive partial products are shifted towards the left position. Partial products are shifted towards the left position, and the final product is obtained after after the sum of these partial products. So we know that the least significant bits are multiplied as we multiplied with the a naught to with b naught, and then a naught with b1 and shifted to the left position. And for the next process, a1 is multiplied with b naught and a1 with b1. And to implement this multiplication process, we require AND gates and half adders to implement this circuits. And mostly it is necessary that we use full adders to produce the sum of partial products, which will be easy for the more number of bits of multiplier and multiplicand. And we can see that the process of to obtain the partial products, we use the AND gates where A naught is multiplied with B naught, and this C naught is obtained at the output. And then the A naught is multiplied with B1. A naught is multiplied with B1, and the output is added to its successive partial product, which is obtained by multiplying A1 with B naught. And these both are added by using a half adder circuit, and the sum from that half adder is produced as C1, and the output carry is transmitted to the next at the input of next half adder circuit, as the carry from this from the sum of these two partial products will be shifted to the next partial product term. And so the next partial product term A1 B1 is added to the previous output carry by using a half adder, and the outputs sum C2 and the output carry C3 are obtained by using this 2 bit by 2 bit binary multiplier as shown in this circuit diagram. Similarly, we can multiply more number of bits and obtain. When the number of bits are increased, the partial products are also increased. And we know that for j multiplier bits and k multiplicand bits, we will need j cross k AND gates and j minus 1 k bit adders to produce a product of j plus k bits. As j is the multiplier and k is the multiplicand, so we will require according to the j multiplier bits and k multiplying bits, and so j cross k AND gates will be needed to find out the multiplication output, and j minus 1 k bit address. J minus 1, for example, if we say that k is equal to 4 and j is equal to 3, means multiply bits are 3 and multiplicand bits are 4, we will need 12, 4 cross 3 12 AND gates, and two 4-bit adders will be required. So in this diagram we can see that two 4-bit adders are used, and 4 plus 4 8 and plus 4 12 AND gates are used to find out the 4-bit by 3-bit binary multiplication process. And here similarly this process is obtained as we have seen in the previous example of the 2-bit by 2-bit binary multiplier case. So as the successive bits are multiplied by we started from the least significant bit A0 and moves on to the most significant bit to A2, and these least significant bits are multiplied with the multiplicand bits and multiplier bits, as we can see in this example. So it is the binary multiplier which can be used to multiply the binary represented numbers and to obtain the output of the products of any number of bits. As the number of bits of the multiplier and multiplicand are increases, the number of gates required and the 4-bit adders will also be increased as the number of bits are getting increased. So this was the lecture about binary multiplier. Inshallah, in our next lecture, we will see about the magnitude comparator, that how two qualities are compared with each other by using binary gates. Okay, so take care. Allah Hafiz. Assalamu alaikum.